All right, so C1 is called the Cartesian plane, okay? That is a fancy word for coordinate grid or your XY axis. Your book will sometimes use any of those. So if you see rectangular coordinate system, that means the same thing. If you see coordinate plane, that means the same thing. Cartesian plane and all of those are the same, okay? As a reminder, hopefully this looks a little familiar. Your x-axis is your horizontal axis. Your y-axis is your vertical axis. Where they meet is the origin. And then your quadrants go top right is the first one and counterclockwise. So quadrant 1, then 2, then 3, then 4. So sometimes you'll be asked about your quadrants. This even carries over even when we get into trig and that kind of stuff. So obviously quadrants are important, starting in the top right and then working your way counterclockwise. All right, we're going to plot some points. So plot your points, label your points, and then right next to it, you can identify which quadrant they lay in. All right, so A, 2, 3 means right 2, up 3, and that would be in what quadrant? Quadrant 1. You can literally use the number 1. You can use the Roman numeral 1. It doesn't matter when you're writing it. Just know those obviously could be interchangeable. B, negative 2, 3, back 2, up 3, and that puts it in? Quadrant 2, so Q2 or Roman numeral 2. 2/3, negative 3, right 2/3 down 3, puts it in? Quadrant 4, which is IV, okay, in Roman numerals. 0, 3, what quadrant is that in? It's a trick question, right? It actually lies on the y-axis. So if it lies on the axis, we say y-axis even if it says quadrants. So it's in between quadrant 1 and 2, but we say y-axis, which means negative 3, 0 would be what? X-axis, good. And 0, 0? Origin. Good job. Feeling pretty smart right now, huh? Don't worry, that won't be a test question. That would be beneath you. Okay, obviously you need to understand that, move forward. So the application of that would be something like this. Determine which quadrant or quadrants satisfy the given information. So number 1 says x is greater than 0 and y is less than 0. If you're a visual person and you want to draw your quadrants, go for it. Go with the first part. Which quadrants would satisfy just x is greater than 0? 1 and 4, the right side, good. Which quadrants would satisfy y is less than 0? 4 and 3. So if this was an or statement, all 3 of those would count. You got to make sure you pay attention to the language, right? Because it's an and statement, I'm looking only where they overlap, which is in quadrant 4. Number 2 says x times y is less than 0. What kind of numbers are less than 0? Negative numbers. So how does a product of 2 numbers result in a negative? One's got to be positive, one's got to be negative. What 2 quadrants does that happen in? 2, where the x is negative, so it's a negative x and a positive y. And 4, where it's a positive x and a negative y. Sometimes it's just 1 quadrant, sometimes it's 2, sometimes it's all of them. Okay, yep.
Wouldn't it be quadrant 3 if both of them are 0?
Not both, but the product. So like you're multiplying. So in 3, they're both negative. If I do a negative times a negative, it makes it go back to positive. So that's what it's not saying x is less than 0 and y is less than 0. It's saying their product is. Does that make sense?
Yeah.
Okay. Good so far? All right, scatter plots are a way of plotting data on an XY axis. So they use information from a given table to graph these little dots that usually form some sort of pattern. They don't always, but they usually form some sort of pattern. If you're looking at an XY chart vertically, the X is going to be on the left The y is on the right. So in this case, the x would be your hours of study. And the right would be the test scores. If it's horizontal, then the x is on the top, the y is on the bottom. This is still hours, and this is still scores. So if there is an overall pattern to this, it might ask you what you can infer from this data. So what's happening to all those dots as I move from left to right? Good. So for the most part, they're increasing, and specific to this data, this would be the more hours of study. The higher the test score. The AP content likes words like increasing, okay? So if you end up ever, like if you when you switch over to AP or you go next year, whatever it is, the wording they would like is as the hours of study increase, the test scores increase. You guys get a little bit more of leeway on how you describe that, but that would be your general consensus. You want to make it tied to the data. So not just increasing, but specifically as the hours increase, the test scores increase. And we're talking about an overall pattern. Like obviously what happens at the end here? What are those last two dots? That all those scores went up, and then what happened? Constant. It came back down and became constant at the end, okay? So it came back down, which could lead, you know, like you could infer a lot of stuff, like that the more hours you study to a certain point, it's helpful. But we've all been up at 3 a.m. trying to study and nothing's sinking in at that point. So sometimes you've maxed out, right? You can't cram it all in and expect magic to happen at the end. So it's a pretty accurate depiction of real study time. But we're talking about an overall pattern when we say an inference. The x goes by 5s and the y's goes by 10s. It doesn't matter. They don't have to go the same as long as within the axis you are consistent. So you want to do the same thing. All right, you're going to make this. So you're going to label your x-axis. You're going to label your y-axis. You have to be consistent on your axes. So actually, all right, so it should have looked something like this. Again, your spacing doesn't have to be exact, but I went by 1s on the x-axis and 10s on the y-axis. And then I plotted my points. What is the overall pattern? Decreasing. If I were to draw a line connecting the beginning to the end, that has a negative slope. It has an overall decreasing pattern, okay? Something happens around 3 that we could say maybe 3 is the hardest, maybe 3 is homecoming week. We don't know what happened during 3, right? But there's a dip there. But the overall pattern would be decreasing. So as the chapter numbers get higher, the test averages decrease. Something like that would be what we could infer from here. Questions? Okay, next up are 2 formulas that you have got to have somewhere stored in your formula bank. And they are the distance and the midpoint. So the distance is the distance between 2 points. It is the square root of x2 minus x1 squared plus y2 minus y1 squared. These answers must be simplified. Meaning if it is a square root, that can be reduced, like something like square root 20. It would have to be rewritten as 2 root 5, something like that. The midpoint is x1 plus x2 over 2, and the y1 plus y2 over 2. These will be in coordinate point form. And again, they must be simplified. So if you're writing out a fraction like 2/4, it needs to be simplified to 1/2. All right, So the first kind of question will be straightforward. Find the distance and the midpoint using the given point. So I'll do that first one with you. It doesn't matter which one I make the x1 and the y and the x2 as long as I'm consistent within the parentheses. So if those are my 1s, these have to be my 2s. Vice versa would have been fine too. And then I plug it in. So d equals the square root of 4 minus a negative 3 squared plus 2 minus 2 squared. What happens when we subtract a negative? Good, becomes positive. So this becomes the square root of 7 squared plus 0 squared, square root 49, which goes back to 7. Your midpoint would be x1 plus x2 over 2 and y1 plus y2 over 2. And I get 1/2, 4 over 2, which is 1/2 and 2. Now a 1/2 can get rewritten as 0.5, but like a 1/3, we don't round to 0.3. If it's exact, you can use either. You don't need to. Might as well do less work, okay? But you can, but not if it's a rounded number. Like a 2/3 cannot be rounded to 0.7. It has to be kept exact. All right, so for the distance, we should have gotten the square root of 10, which can't break down. Well, it does, but it's 2 and 5, nothing repeats, so it doesn't get simplified. And the midpoint, negative 3 halves and 7 halves, which also can be like negative 1.5 and 3.5, but you don't even have to do that. Like, if you don't have to do it, save yourself the time. Raise your hand if you got both right. Great. Questions on midpoint or distance? So before we get to the next thing, I just want you to know, so like if you are one of those people that like square roots are your enemy, like you've never been able to really like simplify well or whatever the skill is that's holding you back, I obviously can't reteach square roots. But if you know you're that person and you know you need to go back and review that stuff, on the top of the module, so on the top of the chapter 1 module, there's a page that says prerequisite skills, what should I already know? And everything you already need to know, click on it. Come on. So if you click on it, it actually takes you to a page of all the Algebra 1 and 2 skills that you need for Chapter 1. So everything that's like a prereq skill, and it's like some stuff is basic and some stuff is complicated. But if you know you need the extra practice on it, this is where this lives. So literally graphing on a coordinate plane, simplifying radicals, those are the things that just from section C1 that we already need, those top 2. And then as we get into the rest of the chapter, you'll see like there's graphing, there's multiplying polynomials, there's factoring practice, because God knows that's not everybody's strong suit, and then quadratic stuff like that. So all of this is on the chapter 1 module. Again, it's at the very top where it links. All right, so now let's apply those coordinate grid. Let's apply those formulas and the coordinates. So verifying the types of polygons. You might see a question that says, verify this is a right triangle. Verify this is an equilateral triangle. Verify this is an isosceles triangle. Okay, as a reminder from geometry, put the right triangle, if they are the 3 sides of a right triangle, then they will satisfy the Pythagorean theorem, which means a squared plus b squared will equal c squared. And you'll actually have to show that work if it says to verify. Isosceles triangles, you would verify that 2 sides have the same length, and equilateral, all 3 sides would have the same length. So it might say find the side lengths and then classify it. That's what your quiz will say. Or it might say something like specifically show that this is a right triangle. So it's already telling you it's a right triangle. You just have to prove it. So using those coordinates, and this font is super cute, but it also makes the 6s look like B's. These are 6s, okay? Using these, I'm going to classify it as a right triangle. So I can graph this. There's a benefit to it because you can either visualize it or also 1, 2, 3, 4, 5, 6, 1, 2, 3. If I plot these, C2, and they are horizontal or vertical, like the C is to the B and the A is to the B, then I can simply just count. So if I need to find the side lengths, From C to B, 1, 2, 3, 4, that side length is 4. From B to A, 1, 2, 3, that side length is 3. Yeah.
If we ever see the 3 and 4, can we just assume the hypotenuse is 5?
So if it said find the length of the third side of this right triangle, yes, you can use your triple 3, 4, 5. Because we're showing that this is a right triangle, we have to prove it. In order to prove it, you have to find the length, and then you have to plug it into the a squared plus b squared equals c squared. But if it just said it is a right triangle, then yes, use your triples. That's why they're there. Yeah. So I'm going to find the distance from A to C because that's the hypotenuse. So square root of 2 minus 6 squared plus 0 minus 3 squared. Negative 4 squared plus negative 3 squared. 16 plus 9. Square root 25, which is 5. So because we do know triples, that makes sense. 3, 4, 5 would be a right triangle. If it's not a triple, which most likely on a quiz or something like that it won't be, then we have to show it using a squared plus b squared equals c squared. Does it matter which one's A, which one's B, and which one's C?
No.
Sort of, yes. Does it matter which one's A and B? No, but what about C? How do I know which one has to be C? The longest or the hypotenuse, right? So which of those three numbers is my C? 5. So I can make it 3 squared plus 4 squared, or 4 squared plus 5 squared. Or 4 squared plus 3 squared. That doesn't matter, but the 5 has to be the C. And since 9 plus 16 gives you 25, that is how you verify this is a right triangle. So if it said show that or verify that, a picture does not show it. You have to use the math to back it up. So you have to show if it's a right triangle, Pythagorean theorem. If it's isosceles, all two sides the same. If it's equilateral, all three sides the same. Your quiz will specifically say, find the lengths of all three sides, and then classify it. Questions so far? All right, last thing is the standard form of a circle. So this is the third formula you need to know from this section. Distance, midpoint, standard form of a circle. X minus h squared plus y minus k squared equals r squared. Where your center is hk and your radius is r. You'll see this a couple different ways. Maybe you're given the center and the radius, and they want you to find the equation. In that case, you're just plugging it in. So it would be x minus 1 squared plus y minus a negative 2 makes that become positive equals r squared, which would be 25. So that's one way you could see a question on this. Here's the center, here's the radius, give me the equation. The other is given the equation, find the center and the radius. When we pull the h and the k out of the equation, we change its sign just like we change it to put it in. You would change it when you take it out again. And you would square root the constant, making the radius 5. Bless you. All right, the other way you'll see it is a question like this. Find the equation of a circle that passes through 3, 4 and has a center of negative 2, 1. So if I'm finding the equation of a circle, my end answer needs to be x in the format of x minus h squared plus y minus k squared equals r squared. And I need a number where h is, where k is, and where r is. What of that do you already know? the h and k. So my h is the -2, the k is my +1. And be careful because make sure the center is what you give the hk values to. People tend to switch these. I don't know the r, but I do have an x and y, right? What I gave you here is an x and y. So what I can do is plug those 4 things in, and all that's left is the r. I'll solve for the r, and then I'll plug that information back in at the end. So my x is 3. My h is -2, so this is minus a -2 squared plus the y is 4 minus the k is 1 squared equals r squared. I'm finding the distance from the center to the point on the circle, which would be the length of the radius. Minus a negative becomes positive, and I get 5 squared plus 3 squared equals r squared. 25 plus 9 equals r squared. So r squared is 34. Okay, so that is your r squared. If it asks for your radius, what's your radius? The square root of 34. So you'd have to square root it. Because I'm plugging it in as r squared, I don't have to go through that step. I don't need to square root it and then re-square it. I could keep it r squared. So now the x stays as the x. Minus a -2 becomes +2. The y stays as the y. The k is a +1, so this would be -1 squared equals my r squared, which is 34. And that whole thing is the standard form. Notice that the signs are opposite, right? From the center to the equation, excuse me, they change, and then it would be vice versa. If I took them out of the equation, they would also change. Questions on anything we talked about so far today? I have one more thing we're going to do, and then I'm going to let you work. All right, so in the homework assignment today, which I'm going to publish in a minute, you'll see that it says complete the PDF, which is a PDF of all those questions. But then it also says create a scatter plot based on the data collected in class. So we're going to collect some data right now, okay? So I'm going to ask you a very difficult question for some people, which is how many siblings do you have? Okay? This means brother, sister, half-brother, half-sister, step-brother, step-sister, whoever you want to claim or not claim, I don't care. It's an individual decision, okay? Families are complicated, okay? So your options are going to be no siblings. You're an only child. You're a very unique individual, by the way. 1 sibling, 2 siblings, or 3 or more. These are your 3 options. Think about your answer. Again, nobody's going to go back and check your genealogy and figure out if you're right or wrong, okay? You're just going to tell me. How many of you have no siblings? Put your hand up. 1, 2, 3. How many of you have 1 sibling? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. How many of you have 2 siblings? 1, 2, 3, 4, 5, 6. Okay. How many of you have 3 or more? 1, 2, 3. Okay. So take a picture of, well, let me write the headings here. Number of siblings and number of students. All right, take a picture of that. That is the data that you need to make your scatter plot, okay? The x-axis, oh,